Hello and welcome to Nikolay's genetics lessons, and today's problem is going to be not about genetics but about logic, and it is very good to practice such problems because logic is applicable to any science, and especially logic and law of probability, which we are going to use today. And here's the problem. Suppose you're at the game show and there are three closed doors. Behind one of them is a car and behind the other two are goats. So what you see here on this picture, consider the following scenario. You pick a door number 1, the game show host looks at the door number 2 and 3 and opens the one with a goat. If both of them have goat, he chooses one randomly. After opening one door with a goat, the game show host gives you the option of switching to the other door or sticking with your original guess. Should you switch doors or not? Let's assume this car is in the room number 1, this goat in the room number 2, and this goat in the room number 3. By the way, you can try to solve this problem on your own first. You may stop video here, and then when you would be ready, you can run video again and you can compare your answer with my answer and explanation. And honestly to tell you, when I tried to solve this problem mentally, I came to the wrong conclusion. Here was my logic. Imagine that, for example, this is you standing here, and there is 3 closed rooms in front of you. I'm not going to draw rooms here, but just turn on your imagination so you don't see neither this car or any of these goats. And here's another person, show host, who can pick inside each room and open any of this, showing what is inside, but of course he only can show a goat. Basically that means that you have to choose only between 2 choices, one car and one goat. Now let's do some mental experiment. For example, I chose room number 1, and for example, this show host would pick into each room, and for example, he is going to open room number 3. So now you don't know what in these 2 rooms, but you sure that in one of these rooms is a car. You already choose room number 1, and what is your probability that this is going to be a car here, because it can also be here. Basically, you are choosing between 2 rooms, and in one is car, in another is a goat. You just don't know in which room. So my logic was that your chances are 50%. 50% probability to choose a car and 50% to choose a goat. And basically you're choosing not between 3 but between 2. And even if you switch your opinion after one room would be open, this is not going to affect our calculations and probability to choose correct answer. In our case, it is a car. Or for example, if your initial choice was room number 2, again, after this room have been opened and you have been shown this goat, you don't know whether a car in this room or in this room. Both of them are closed, and your chances that you're going to choose goat is 50%, or your chances that here is going to be a car also 50%, and decision to switch to the different room probably have no any sense. Probably 99% of you also would think as I initially thought, but actually not the correct answer. And you can get a correct answer only if you start filling this table. Let's try all possible variants. For example, your choice is gate or room number 1, and here is a car, so prize door is number 1 also. Game show host can open whether this door or this door. Anyway, you have to choose between number 1 and number 2, or between number 1 and number 3. If you didn't switch the door, then you're going to win. So you choose number 1 and the car was in the room number 1, so you win. But if you choose to switch to a different room, this is going to be, for example, room number 2, where the goat is, you're going to lose. So let's say if you switch, you lose. So lose in this case. Your choices also can be gate number 2 or room number 2. Our car in the room number 1. So still number 1. This time, as you see, your choice is a goat, but you don't know it. And host, looking at all 3 rooms, of course opens this room number 3, showing you a goat. And again, you don't know what is in these 2 rooms, but you know that in 1 is a car, in 1 is a goat. And you choose not to switch your opinion, and you stick to the room number 2. So what's going to happen in this case? In this case, you're going to lose. But if you switch, for example, you say, no, I'm going to open number 1 instead of initial number 2, you're going to win. So let's put win in a case if you change your opinion. And the third variant would be, for example, if you choose door number 3 or room number 3. So let's put it here, number 3. But the price in the room number 1. Show host, look into all 3 rooms, and he's going to open this room because your choice is number 3. And again, you know that whether in this room or in this room have to be a car. If you stick with your first choice, then what is going to happen? You're going to lose. So the price door is still number 1, so you are going to lose. But if you change your opinion, and you can change between number 3 and number 1, you're going to win. So let's put win here. Now let's assume that the car is in the room number 2. Let's do this mental experiment again. You choose a room number 1, but this time, as you see, the car in the room number 2. You choose number 1, the car in the room number 2. Of course, our show host, when he look inside all 3 rooms, he is going to open a room number 3 with a goat. So now, here's your choice. You know that in one of this room is a car, in another is a goat. If you're not going to change your mind, and you will stick with your first choice, initial choice, number 1, you're going to lose. So let's put here. You're going to lose. But if you change your mind, and again, your choice was number 1, if you change your mind and say, no, I want it to be room number 2 instead of my initial number 1, you're going to win. So let's put win here. Which are other possible variants that you may say that car in the room number 2, and it is in the room number 2. So this is your choice, and show host can open whether this door or this door. You're still going to be with a room, closed room with a car, and one of these variants which contain a goat. If you don't switch your initial choice, you're going to win this time. You're going to win because a car in the room number 2. But if you say choose to switch the room, for example, to room number 1, in this case, you're going to lose. So you're going to lose. Now, let's say you initially choose a room number 3, where the goat is, and show host look into all 3 rooms and open this door and show you the goat here. so you don't know whether the car in room number 2 or 3. And again, you choose not to switch your initial choice, and in this case you're going to lose because you chose room number 3 and car in the room number 2. You stick with your opinion, initial opinion, and you're going to lose. But if you choose to switch, again, room number 3 is your initial choice. Room number 1 would be open in this case. And if you switch to room number 2, you're going to win. So if you switch, you're going to win. Now let's also imagine that the car is in the room number 3. Again, you can choose a room number 1, a room number 2, and a room number 3. 3 variants. If you choose room number 1, show host will take a look inside each room and is going to open a room number 2. So now you have to choose between room number 1 and 3. If you choose not to switch your initial choice, you're going to lose because the car is in the room number 3. So you're going to lose. So let's put here lose. But if you choose to switch, your initial choice was room number 1, the car is number 3, number 2 is open by the show host, and in this case, if you switch from 1 to 3, you're going to win. Now let's assume that your initial choice was room number 2. Show host will take a look in all 3 rooms and is going to open a room number 1. Again, in this case, you're choosing between room number 2 and 3. The prize door is door number 3. If you stick with your initial choice, room number 2, you're going to get a goat. So you're going to lose. You're going to lose. But if you choose to switch to number 3, you're going to win. So let's put win here. And the last variant would be your choice is room number 3 and prize door is number 3. So let's also put 3 here. And again, show host will take a look in all 3 rooms and is going to open any of the rooms with number 1 or 2. So you have to choose between 2 and 3 or 3 and 1 because one of this door would be open. Let's say that show host choose to open room number 1. So you have to choose between room number 2 and 3. If you again stay with your initial opinion, you are going to win in this case because your choice was room number 3 and the car in the room number 3. If you choose to switch to the different room, you're going to lose in this case. So now we have listed all possible variants. Now let's count. If you choose not to switch your initial opinion, 1, 2, 3 variants that you're going to win. But if you choose to switch your initial opinion, 1, 2, 3, 4, 5, 6 variants that you're going to win. So our answer to the question, should you switch doors or not, have to be you have to switch them. This is how you increase your probability to win. In this type of problems, it is very important to list all possible combinations, because if you do mental exercising with couple examples, you may come to wrong conclusion that switching rooms have no effect on the final outcome. But now, when we list all the possible combinations, we have found that switching rooms will give you much higher probability to win. And this is all for today. Subscribe and see you in the next video. Goodbye.